Hi, this is Jeline from the Honors Tutorial. Our topic for today is about inverse of a function. It focuses on the table of values. This is under General Mathematics for Mathematics 11. So let's continue now. Our example is f of x equals 2x plus 3. So this is considered to be our original function. So I will be writing the solution here. So let's write the word solution. And then I will be writing here letter A. Let's label it as original function. And then we will be copying the given since that is the original function, that is f of x is equal to 2x plus 3. And then f of x will be changed to y. So we have here y equals 2x plus 3. Now, this is our original function. It is same with f of x equals to x plus 3. But the problem here, since we are discussing about the inverse of a function, we have to change this into inverse function. So let's write here inverse function. For now, we will be copying the original function, which is y equals to x plus 3. And then after that, we have to change the places of x and y. So it will become x equals to y plus 3. And then our goal is to have y only either at the left or the right side of the equation. So we will be transposing positive 3 here at the left side of the equation. So we have here 2y and then x minus 3. Then let's change places without changing the signs of each term. So we have here 2y is equal to x minus 3. Again, our goal here is to have y only at the left side of the equation. So therefore, we are going to divide both sides by 2 to eliminate the numerical coefficient. So we have here y equals x minus 3 over 2. That's why we can say that the inverse of function x is equal to x minus 3 over 2. So this is the inverse that we are going to use. Now, we are not yet done with that because as I have mentioned, we have to do the table of values. Let me just do the table of values for the original function first. I will write it here. So let's write C. Table of values. This is for original function. Now let's have a table and I will be dividing it by 8. So it's 2, 3, 4, 5, 6, 7, 8. And then we have here x, y. And then for the values of x, I choose negative 3, negative 2, negative 1, 0, 1, 2, and 3. For table of values for the original function for x, you can choose any of the numbers on the number line that you want to. But it is easier to use this, which is 0, 1, 2, 3, or 0, negative 1, negative 2, and negative 3. Some of mathematicians use 0 up to negative 2 and 0 up to positive 2. So it is up to you. If you want to use numbers up to -5 and up to +5, it's fine. As long as it will benefit you and at the end, your graph is still the same and the values of y is correct. Okay, so let's solve for the values of y now. Let's have x equals -3. So we have here 1. X equals -3. So let's have the original function. So that is y equals 2x plus 3. So let's substitute the value of x, that is -3. So that's 2 times -3 plus 3. So we have here y equals 2 times -3, that's -6 plus 3. So we have here y equals -6 plus 3 is -3. So the value of y when x is -3 is equal to -3 also. Next, let's have the value of y when x is equal to -2. So x is equal to -2. The original function is y equals 2x plus 3. Substitute the value of x, that's -2. So we have here y equals 2 times -2 plus 3. So that's y equals 2 times -2 is -4 plus 3. So therefore, y is equal to -1. So when x is equal to -2, y is equal to -1. Next, let's solve for the values of y when x is equal to -1. So we have here x equals -1. Original function y equals 2x plus 3. Value of x, that is -1. So y equals 2 times -1 plus 3. So y equals 2 times -1, that's -2 plus 3. So y equals 1. When x is equal to -1, y is equal to +1. Next, let's solve for the value of y when x is equal to 0. Same process. So we have here x equals 0. So original function, that is y equals 2x plus 3. Substitute the value of x. So we have here y equals 2 times 0 plus 3. So we have here y equals 2 times 0, that's 0 plus 3. So we have here y equals 3. So the value of y when x is 0 is 3. Let's continue solving. Let me just erase this part. Let's have the value of y when x is equal to 1. Original function is y equals 2x plus 3. So that's y equals 2 times the value of x, that's 1 plus 3. So y equals 2 times 1, that's 2 plus 3. So y is equal to 5. When x is equal to 1, y is equal to 5. Let's solve for the value of y when x is equal to 2. So we have here x equals 2. So that is y equals 2x plus 3. So y equals 2 times the value of x, that's 2 plus 3. Y is equal to 2 times 2, that's 4 plus 3. So therefore, y is equal to 7. So let's have 7 here. Then let's proceed when x is equal to +3. So let me just erase this part for you. This part. So we have here x equals 3. Original function is y equals 2x plus 3. Substitute the value of x, that is 3, so that is 2 times 3 plus 3. So y equals 2 times 3, that's 6 plus 3. Y equals 9. So the answer here is 9. So this is the table of values for the original function, but don't forget that we are also solving for the inverse function. But don't worry, because for the inverse function, let me just write table of values for inverse function. For table of values for the inverse function, no need to compute, but make sure that you will be having 8 divisions here also, just like original function. So that's 2, 3, 4, 5, 6, 7, 8. And then let's have x and y here. You have to interchange the places of x. So in the original function, the values of x is negative 3, negative 2, negative 1, 0, 1, 2, 3. It will become the value of our y now. So that's negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then the values of y will become the x values. So we have here negative 3, negative 1, 1, 3, 5, 7, and 9. And that's it for the table of values for the original and the inverse function. If you have questions, clarifications regarding this topic, you can message us via FB page The Honors Tutorial. And also, these coordinates or the table of values are used to graph this function. Okay? Thank you and God bless.